Hello, ladies and gentlemen of my physical sciences. Mr. Escox back. We are continuing on in Chapter 6. We're going to do the first part of Chapter 6, Section 2. We have been talking about compounds and atomic ratios. How is a compound different from an element? An element is one sole type of atom. A compound is several types, one or more types of atoms chemically combined. So today we're going to talk about how those chemical bonds happen. We're going to get through We're going to go through ionic bonds, excuse me, and then we'll finish this up on the next day. Chemical bonds hold compounds together. A chemical bond is involved between the electrons, the valence electrons of two atoms, and it's always just the valence electrons. The valence electrons are the outermost shell. When we talk about atoms, so you either transfer electrons or you share electrons. Atoms that transfer electrons are going to give it or take it. When they share, it stays between the two. Atoms of group 1, group 2, and group 13. So you have the alkali metals, alkaline earth metals, and the boron group all lose their electrons. If you look at these pictures here, here's sodium, has 2, it has 8, and then only one sole electron. Boron has 2 in its first shell and then has 3, so it's going to lose all 3 of them. Calcium has 2, 8, 8, and then only 2 in its outer shell. It loses both. So sodium loses 1, becomes a positive 1. Calcium loses 2. Boron loses all 3. So if I show you an example, let's do lithium. Lithium has 3 protons. It has 4 neutrons, so therefore it will have 3 electrons. The first shell will hold 2. And then this next shell has only 1 electron. And it doesn't really want it, so that electron tends to leave and go somewhere else. So it loses that. Everything in that group, when it loses an electron, becomes a positive 1. Remember, 0 taking away a negative 1 equals positive 1. If you look at something like magnesium, magnesium has 12 protons, its atomic number. It has an atomic mass of 24, so it has 12 neutrons. Well, you still have 2 electrons in the first shell, 8 in the second shell. So it's full. So 2 plus 8 is 10. I need 2 more. This outer shell has 2 more electrons in it. So it's easier to lose those 2 than gain 6. So both these electrons will leave. So if I have a 0 charge, subtract 2 negatives, my overall charge, positive 2. Everything in group 2 will be a positive 2. And last but not least, if we look at aluminum, aluminum is 13 protons. It has an atomic mass of 27, so it has 14 neutrons. So it would be 2, then 8, and then finally 3. 1, 2, 3. It will lose those 3. 0 minus 3 gives us a positive 3 charge. Two atoms are walking down the street. It says, I lost an electron. The second says, are you sure? Then the first one responds, I'm positive. Oh, if you lose an electron, you become positive. Speaking of transfers, you either lose 1, 2, or 3, or you tend to gain 1, 2, or 3. Group 15 elements, which would be the nitrogen group, will gain 3. 16 gains 2, 17 group, which is halogens, gains only 1. So if I draw my fluorine in here, fluorine has 9 protons, 10 neutrons. So we'll have 9 electrons. You have 2. The next shell will have 7. And it really wants to get to the magic number of 8 because it wants 1 for this last spot. If it gains an electron, it will have 10 negative charges and 9 positive charges. Negative 10 plus 9 equals negative 1. I know I've told you guys this before, but you are more than welcome to write your charges above this on your periodic table. Everything in this group is plus 1. This has 2 valence electrons, they go away, that's plus 2. In the middle here, there's plus 1, plus 2, or plus 3, and they vary in there. Everything in group 13 is plus 3. Group 14 is plus or minus 4. That's the pivot one. Nitrogen wants to start gaining electrons. So nitrogen is where it starts becoming negative. So this group here is negative 3. Oxygen group wants to gain 2, so when they gain 2, they become negative 2. Our halogens become negative 1. They only gain 1 electron. Like I said, you are more than welcome to keep that written on your periodic table. Ionic compounds form between a positive and negative ion. So when you lose electrons, you become positive. When you gain that electron, you become negative. This here is by far the most common. This is table salt. So sodium loses its outer valence electron right here, and it transfers it to the chlorine, which really wants it. Chlorine becomes negative, sodium becomes positive, and they attract, kind of like a magnet. The opposite ends of a magnet. The positives and negatives attract. Down here, you'll see calcium and sulfur. Well, and sodium and oxygen. So sodium forms a positive 1 charge, oxygen forms a negative 2. We have to balance these out. So it takes 2 sodium. So sodium 2, which will give me 2 positives. I already have 2 negatives. Oxygen. Calcium forms positive 2. Sulfur forms a negative 2. So this one, you don't need any balancing, so it just becomes calcium sulfide. Ionic compounds form crystals. This is a crystal of salt. You get that regular repeating pattern with the positives and negatives that keep repeating himself. So the smaller one is our positive. The larger ones are the negatives. And these positives and negatives are what give ionic compounds their shape. Okay, when we're naming ionic compounds, you take the name of the metal, that's your positive, and then you take that by itself, and you take the negative ion, often called the cation. That ion you add IDE, so sodium plus chlorine. Well, we drop the ion and add IDE, it becomes sodium chloride. So let's try a couple here. So A is potassium. And it's fluorine. So we drop the ion and potassium, fluoride. That's not what you put in toothpaste. What's in toothpaste is sodium fluoride. Magnesium and phosphorus, that becomes magnesium. Phosphide. All right, so that takes me to the end of ionic compounds and the end of this video. So I'm going to run out. We're going to come back next time and talk about covalent bonds and we'll talk about metallic bonds. But until then, if you're reading them for this, be good, safe. See you later.